Hello students, welcome to Mathematics Study channel. In the last class, we have discussed about continuity and differentiability. In continuity and differentiability, we have already completed so many exercise. We have already completed in exercise 7.5. We have already completed so many questions. So today we are going to solve the remaining problem of exercise 5.7. So we have already done question number up to 11. Today we are going to start from question number 12. So question number 12 is, if y equal to cos inverse of x, then find d2y dx2 in terms of y alone. So first it is given, let's try to solve question number 12. It is given here y is equal to, it is given cos inverse of x. Since y alone, then this can be written as x equal to cos of y. Now differentiating with respect to y. Now differentiating with respect to y, if we differentiating with respect to y, then this is equal to dx dy. This is equal dy into cos of y. This is equal to what? This is equal to, we know we know the formula ddx of cos x is equal to what? Minus sin of x. So dy cos of y equal to what? Minus sin of y. So sin y can be written as 1 by cosec y. 1 by cosec y, give here minus. Okay. So therefore we have dy dx equal to what? dy dx equal to minus cosec y. Okay. The dy dx equal to what? Minus cosec y. Now differentiating with respect to x. Differentiating with respect to x, we get, if we differentiating this with respect to x, then we have, this is d2y by dx2, this is equal to minus ddx of cosec y. Okay, cosec y. This implies that d2y dx2 is equal to minus, we know the formula ddx of cosec x equal to, we know the formula ddx of cosec x equal to minus cosec x into cot x. So use this formula in this equation, then we have minus cosec y, means here is cosec y into cot of y. If we differentiate y, then we get dy dx. So this implies that d2y by dx2 equal, minus minus is plus, it is cosec y into cot y. Okay, dy dx equal to what? In equation, in that one, we have dy dx equal to what? dy dx equal to minus cosec y. Just we put the value of dy dx here. Okay, so this implies that d2y by dx2 equal minus cosec y into cosec y equal to what? Cosec y into cosec y is cosec square y into cot y. This is the final answer. Now we are going to solve question number 13. So question number 13 is, if y equal to 3 cos log x plus 4 sin log x, so that x square y2 plus x y1 plus y equal to 0. So first, y is what? Question number 13, how to solve? like here it is given y equal to y is given here, y equal to what? Y equal to 3 cos log x plus 3 cos log x plus 4 sin log of x, it is given. Now if we differentiating this with respect to x, then what we get? Differentiating with respect to x, we get, if we differentiating this, then we have dy dx equal to ddx of 3 cos log x, okay, cos log x plus ddx of 4 is constant out, okay, sin log of x. So this is equal to what? 3 is constant out. If we differentiate ddx of cos x, then we know the formula ddx of cos x is minus sin x, okay, minus sin. Here x is what? X is log of x, so x is log of x, okay. This is again according to chain rule. First we differentiate cos, now we are going to differentiate log of x, then ddx of log of x, okay, according to chain rule, plus 4 into ddx of sin x equal to, we know the formula, ddx of sin x equal to what? Ddx of sin x is cos x, so this is cos x is what? X is log of x. According to chain rule, again ddx of log of x, okay. So this is equal to what? Dy dx can be written as y1, so this is y1, dy dx can be written as y1. So this implies that y1 is equal to, this is minus 3 sin log x into ddx of log x equal to, we know the formula, ddx of log x is 1 by x plus 4 cos log x into ddx of log x equal to what? Ddx of log x is 1 by x. If we multiplying both side by x, then what we get? Now multiplying both side by x, then we had x y1, this is equal to minus 3 sin into log x. Since we are multiplying by x, then this x and this x cancel out, plus 4 cos log x, and this x is cancelled. So what we have? We have x y1 equal to minus 3 sin log x plus 4 cos log of x. This is a suppose equation number 1. Differentiating again, differentiating with respect to x, we get, if we differentiate this equation again, then we have ddx of x y1 is equal to ddx of this, ddx of minus 3 sin x log x plus 4 cos log x, okay. So how to differentiate this? Then using u into v method, then we have what? We have x is constant, then ddx of y1 plus y, here y1 is constant, and ddx of x, this is equal to minus 3 is constant, okay. So ddx of log x equal, ddx of sin x, we know the formula, ddx of sin x is what? Ddx of sin x is cos of x, cos, here x is log x. If we differentiate log x, then ddx of log of x, here plus 4 into dx of cos x equal to, you know the formula, dx of cos x equal to what? Minus sin x. X is log x. So into dx of what? Into dx of log of x. So this implies that x into d dx of y1 equal to what? That means d2y by dx2. d2y by dx2 is written as y2. So this is y2. Okay. d2y by dx2 is what? dx2 is y2. So this is y2 plus y1. ddx of x is 1. This is equal to, this is 3 minus 3 cos log x. So ddx of log x equal to, we know, 1 by x. This is minus 4 sin log x. ddx of log x equal to, we know the formula, 1 by x. So this implies that if we multiplying both sides by x, then what we have, this is x y2. Sorry, if we multiplying by x, then this is x squared plus x y1 is equal to minus 3 cos log x minus 4 sin log x. So, we are to show that, what we are to show that, we are to show that x square y2 plus x y1 plus y equal to 0. So this implies x square y2 plus x y1, if we are taking minus common, then this is equal to 3 cos log of x plus 4 sin log of x. So this is equal to what? This implies that x square y2 plus x y1 is equal to minus, the y is what? Y is 3 cos log x plus 4 sin log x. So this can be the value of, this is y. This implies that x square y2 plus x y1 plus y equal to 0. Hence proof. Now we are going to solve question number 14. So question number 14 is, if y equal a into e to the power mx plus b into e to the power nx, then show that d2y dx2 minus m plus n whole into dy dx plus mn y equal to 0. So let's try to solve this problem. Question number 14. Here y equal to, y is given here. So y equal to what? Y equal to a into e to the power mx, a into e to the power nx plus b into e to the power nx. It is given. So if this is equation number 1, differentiating this equation with respect to x, differentiating with respect to x, we have, if we differentiating this, then we get dy dx. This is equal to ddx of a into e to the power mx plus b into e to the power nx. So this implies that dy dx is equal to, here a is constant, to a is out, ddx of e to the power mx equal to what? ddx of e to the power mx is e to the power mx into ddx of mx. First we differentiate e to the power mx. Now we are going to differentiate mx. So ddx of, according to chain rule, plus here b is constant into ddx of, sorry, b is constant, then ddx of e to the power nx equal to same formula nx. Again we differentiate nx according to chain rule. So this implies that dy dx is equal to a into e to the power mx into ddx of mx equal to m is constant, so ddx of x is 1, so n, plus b into e to the power nx into ddx of nx, n is constant here and ddx of x is 1, so here is n only. So finally we had dy dx equal to what? Equal to m into a e to the power mx plus n into b e to the power nx. This is dy dx. If this is equation number 2. Now again differentiating equation 2 with respect to x. Again differentiating equation 2 with respect to x, then we have what we have. If we differentiate dy dx by with respect to x, then we get d2y by dx2. This is equal to m a is constant, m a is constant, and ddx of e to the power mx plus here nb is constant, ddx of e to the power nx. This implies that d2y by dx2 is equal to m into a, ddx of e to the power mx is e to the power mx. Again if we differentiating mx, then we get here m plus n into b e to the power nx. If we differentiate nx according to chain rule, then we find n. Okay, so finally we have d2y by dx2 equal to m into m square. Okay, m square a into e to the power mx plus n into n is n square b into e to the power nx. This is equation number 3. Now we are to prove that, what we are to prove that, now we are going to prove that d square y d2y by dx2 equal minus m plus n whole into dy dx plus mn y equal to 0. Now taking left hand side, so left hand side equal to what? Left hand side is d2y by dx2, okay, minus m plus n whole into dy dx plus mn y. This now we are going to show this is equal to 0. So how to solve this? This is equal to, here we know the value of d2y by dx2. So this is the value of d2y by dx2. So right here m square a into a to the power mx plus n square b into e to the power nx. Okay, minus m plus n. So right here m plus n. Okay, dy dx. We know the value of dy dx. What is the value of dy dx? Value of dy dx is m a into e to the power mx plus nb into e to the power nx. Okay, this is the value of dy dx plus mn into what? Into y. We know the value of y. What is the value of y? Y is a e to the power mx plus b e to the power nx. Now we are calculating how to calculate this. This is equal to a m square e to the power mx plus b n square e to the power nx. If we multiplying this with this, then what we get? This is minus m into m square into a e to the power mx. Okay, so again this multiplying with this, then we have minus m into n mn. Okay, mn into b e to the power nx. Again if we multiplying this with this, then this is also minus mn into a e to the power mx e to the power mx. This is minus this is minus n into n is n square b e to the power nx plus mn e to the power mx plus b mn e to the power nx. This is equal to m square e to the power mx is plus, so here is this term and this term is cancelled, bn square e to the power nx, here is also bn square e to the power nx, this term also cancel out, m square, this and this and this and these are cancel out. Okay, here is mn b to the power nx, here is also plus mn b into the power nx, this cancel and this cancel, so this is equal to 0, equal to right hand side. Now we are going to solve question number 15. So question number 15 is y equal to 500 e to the power 7x plus 600 e to the power minus 7x, so that d2y dx2 equal to 49y. So it is a very simple problem. Question number 15. Here it is given here y is equal to what? Y is equal to 500 e to the power 7x plus 600 into e to the power minus 7x. This is given here. So first, this is suppose equation number 1. Now differentiating with respect to x, differentiating with respect to x, we get, if we differentiating, then dy dx, this is equal to 500 is constant. Okay, so ddx of e to the power 7x plus 600 is constant, ddx of e to the power minus 7x. So this is equal to 500 into e to the power x is e to the power x. If we differentiate this, then we have 7. Okay, plus again 600 into ddx of e to the power minus 7 is minus e to the power minus 7x into what? Into 7. So this is equal to 500, this into this 3500 into e to the power 7x, this is minus 6 I 7 42,000 e to the power minus 7x. This is the dy dx. This is the dy dx. Again differentiating with respect to x, this is dy dx. Again differentiating with respect to x, then we have, if we differentiating again with respect to x, then d2y by dx2, this is equal to 3500 ddx of e to the power 7x minus 4200 ddx of e to the power minus 7x. So this is equal to 500 ddx of e to the power x is e to the power 7x into 7 minus 4200 e to the power minus 7x minus e to the power minus 7x into 7. So this is equal to, this implies d2y by dx2, this is equal to this. So what is the answer? So answer is what here? If we taking common here, this is d2y by dx2, taking common 49, then we have what we have 500 e to the power 7x, this minus minus is plus, then if we taking common 49, then it is 600 e to the power minus 7x. So this implies d2y by dx2, this is equal to 49. The value of this is what? The value of this is y. This is equal to y. This is the answer, hence proof. Okay. the d2y by dx2 equal to 49. We have to prove that. So lastly we get d2y by dx2 equal to 49. This is the answer. Okay. Now we are going to solve question number 16. It is a very important problem. Question number 16. So if e to the power x whole into x plus y equal to 1, show that d2y by dx2 equal to dy dx whole square. Then it is given here. What is given here? Given here e to the power x whole into x plus 1 equal to what? Y equal e to the power, sorry, this is not x, this is y. E to the power y whole into x plus 1 equal to 1. It is given. So we have to prove that. What we have to prove that? We have to prove that this one d2y by dx2, this is equal to dy dx whole square. We have to prove this. Okay. So first of all, this can be written as e to the power y is equal to 1 by x plus 1. Okay. So this equation can be written in this form also. So now differentiating with respect to x, we get. If we differentiating this with respect to x, then what we get? ddx of e to the power y is equal to dx of x plus 1 can be written as x plus 1 whole to the power minus 1. Okay. So if we differentiating e to the power y, then we get e to the power y. Again, if we differentiating y, then we get dy dx. This is equal to ddx of x plus 1 whole to the power minus 1 is what? ddx of x plus 1 minus 1 is minus 1 into what? X plus 1 whole to the power minus 1 is minus 2. So this implies that e to the power y into dy dx is equal to, this can be written as minus 1 by x plus 1 whole square. Okay. So finally we have what we have? E to the power y into dy dx equal to minus 1 by x plus 1 whole square. Okay. So the value of e to the power x is what? The value of e to the power x is, sorry, e to the power y is, the value of e to the power y is what? 1 by x plus 1 into dy dx. This is equal to minus 1 by x plus 1 whole square. X plus 1, then what we get? Multiplying both sides by x plus 1, then this x plus 1 and x plus 1 is cancelled here. Remaining is dy dx. This is equal to, if we multiplying by 1 x plus 1, then we get here minus 1 by x plus 1. Okay. Again differentiating this with respect to x, again differentiating with respect to x, we get, if we differentiating this with respect to x, then we get d2y by dx2. This is equal to, here is minus, so again differentiating, then this can be written as x plus 1 whole to the power minus 1. So this implies that d2y by dx2, this is equal to minus, so ddx of this is minus 1 by what? 1 by x plus 1 whole square. Okay, so this is equal to d2y by dx2, this is equal to what? Minus minus is plus, 1 by x plus 1 whole square. 1 by x plus 1 whole square can be written as, how? Can be written as minus 1 by x plus 1 whole square. Because every square number is positive, so this is equal to what? This is equal to the value of dy dx. Here value of dy dx equal to what? Value of dy dx, here we get value of dy dx is minus 1 by x plus 1. So in place of minus 1 by x plus 1, we can write dy dx. So here is whole square. So we are going to prove, what we are going to prove? That d2y by dx2, this is equal to what? We have dy by dx whole square, hence proof. Now we are going to solve question number 17. It is the last question of this class. Okay, so 17 is if y equal to, it is given here, if y equal to tan inverse of x whole square, so that x square plus 1 whole square into y2 plus, what is y2? y2 means d2y by dx2, that means second order derivatives. y2 means second order derivatives of, okay, so 2x plus 2x x square plus 1 whole into y1. y1 means first order derivatives equal to 2. So let's try to solve this question number 17. Here y is given here, y equal to tan inverse of x whole square. So this is given. Now differentiating with respect to x, differentiating with respect to x, we get, if we differentiating this with respect to x, then this is dy dx, this is equal to ddx of tan inverse of x whole square. This is equal to, first we know the formula, ddx of x to the power n equal to what? ddx of x to the power n is n into x to the power n minus 1. Then we get here 2 into tan inverse of x. Again, according to chain rule, now we are going to differentiate tan inverse of x. So this implies that dy dx is equal to what? 2 tan inverse of x into ddx of tan inverse of x. We know the formula, that ddx of tan inverse of x equal to what? 1 by 1 plus x square. So finally we had dy dx can be written as y1. Okay, so this is equal to what? 2 tan inverse of x into 1 by 1 plus x square. So finally we had y1, that means dy dx equal to this. Now again, this implies that x square plus 1, this can be multiplying with x square plus 1 into y1, this is equal to 2 tan inverse of x. Finally we get this. Again differentiating with respect to x, then we have what? We have ddx of x square plus 1 into y1. Okay, this is equal to 2 is constant here, so ddx of tan inverse of x. We use u into v formula. So ddx of this is u and this is v. Then first u is x square plus 1 into ddx of y1. Okay, plus here y1 is constant and ddx of what? ddx of this one, x square plus 1. This is equal to what? 2 into ddx of tan inverse of x. Already we know the formula, ddx of tan inverse of x is 1 by 1 plus x square. So this implies that if we multiplying this with this, then this is x square plus 1. This is ddx of y1 means what? Second order derivatives. Then this can be written as y2 plus y1 into ddx of x square is what? ddx of x square is 2x plus ddx of 1 is 0. This is equal to 2 by 1 plus x square. Okay, now multiplying both side by x square plus 1, then we get, now multiplying both side by x square plus 1, then this is x square plus 1 whole square into y2. This is equal, this is plus multiplying this with this, then here we get, how do we get? X square plus 1 into 2x, okay, into 2x y1, this is equal to 2, because we are multiplying x square plus 1 by both sides. So the final answer is what? The final answer is, this is the final answer. This is the final answer. X square plus 1 whole square y2 plus x square plus 1 2x into y1 equal to 2.